Solve this today's LeetCode problem. This is LeetCode hard minimum falling path sum 2. But believe me, this is not an hard problem. This it if this makes a hard, but with this constant, this is not a hard problem. This will be a medium problem. If we change this constants to some high, then it will be hard, right? So let's see what it is. So this is given n cross n integer matrix grid, and we need to return the minimum sum of falling path sum with non-zero shift. A falling path with non-zero shift is a choice of exactly one element from each row of grid such that no elements chosen in adjacent row are in the same column. Okay. So what we need to find in this, we have to find the summation of minimum summation of falling path sum. What is falling path sum? That I can only choose a single element in a particular row, and after that in a adjacent row I cannot choose a same column a number which we have chosen in previous. Like if I choose 0 in my first row, then I can't choose 0 in a zeroth column in my second row also, right? So in adjacent row I need to choose a different column for for exactly including in my summation variable, right? So this is how this is what the problem is, that we need to find the minimum sum such that I can choose only a single element in a particular row, and I can choose same column for adjacent rows, right? So for the zeros, for first column here, I can choose 0, but for second column, for second row, I can't choose 0 as a my I can't choose second for zeroth column to my answer. I can choose 1 or 2, right? And at third I can choose 0. I can't choose 1 because we have chosen 1 in my previous. So I can choose 2. So this is how we get 13 here, right? Because 157 is only I can take, which give me a minimum sum. If I take 2, 4, 8, then it will give me 20, 14, which is not an which is greater than 13. If I take 2, 6, 8, this will be 16, which is greater than 13. So 157 is a optimal. So here we can see, here we need to see that how we will determine that which how we will determine that which how can I know that which elements we have chosen for before which column we have chosen before this row, current row, right? So and if you see so is it don't you see here one thing, that I need to figure out anyhow I need to figure out anyhow that I need to figure out anyhow that how, that the previous column I need to check every time that what I have chosen in my previous rows, which column I have chosen in my previous rows. I need to choose every time so that I will not choose that particular column in my second row or the third row or the adjacent rows, right? So if there is any dependency, in my previous state, then you should you should think of dp. And one thing particular one thing particular I'm confirmed that I will use dp by seeing this constants, that this is given 200 only. So it means I can use to n to the power q or n square, right? I can simply make this happen to n cube or n square, right? Because this n and the length of grid and the height of the grid is n, which is 200 only. So n cube will be valid or n square will be valid. So after seeing that, I need to maintain a track of. I need to see the previous state. What is the previous column or length? So it's a tip. So here in this question, there is a dependency on previous previous uh, previous row, that which column I have chosen already, so that I don't choose the same column again in my next row, right, for summation. So there's a dependency on previous row, and so I think of dp, and this and I'm sure, and I'm sure enough that this question will be can be solved with dp by seeing the constraints, right, by seeing the constraints. So I am make sure that this can be done in nq and square, right? So how we can done is, how we can see is, so this is basically a simple recursive problem. That's why I have told that this is not an hard problem, this is a medium problem. If you see this constraints, right, 200. So what we can do, we can simply choose any elements from first row, then I will store that row, I will store that column, and I will go to second, and I will again take all the columns from that, all the elements from that row, except that particular column which is already taken by the previous row, right? And I will take the minimum of all the summation which you have included in that, right? So what do I mean is, I will choose all the 1 to 3, right? I will take all the 1 to 3. So for particular one or for particular 3, what will I do? So for particular 1 and particular 1 2, right? So what will I do for this one? Suppose I choose this one for first row, this is for first row, this is first row. So I suppose I choose 1 because I can choose anything. So suppose I choose 1. So for second row, what can be an option here? So for second row, I can choose 4. No, because I have chosen already 1, so I can't choose 4. So what do I have option? I can choose a 5. I can choose 5. I have option of 5. Again I have option of 6, right? For second, I have option of 4, or I have option of 6, right? And for again 3, what I have option? You can choose 4 or 5. This all I have option, right? This 4 and 5 are option. This is for particular second row. This is for particular second row. This we all have options here, right? This we all have options for second row, right? So now for the third row, what can be an options here? So if I include 5 in the second row, I can't choose the second column, which is this is second column. So I can't choose in third row second same column, right? So what I can do is, I can simply just a minute, just making some arrows for making you understand this. Just give me a sec. uh, yeah. Just trying to make you understand this. Yeah. So suppose I have already taken this 5 here in second. So this is 5 in the second column. So what are the options of with me? I can choose either 7, or I can choose either 9, right? Or what I can choose, if I choose 6, then I have option of 8 and 9, right? Again for the same, if I have 4, then I have option of 8, then 9. Again For 6, I have option of 7 and 8. Again for 4, I have option of 8 and 9. So I just need to keep track of previous elements, that what previous elements are not. So 5, 4, 5, 7, 9. So among this all, I will take summation of 157, 159, 168, 169, 248, 249, 267, 268, 348, 349, 357, 359. So among this all, which will be the minimum will be my answer. It's as simple as that. So if I take 157, this will be 516 and to 13. So this is 13. 159 is greater than 13. 168 is greater than 13. 169 is greater than 13. Again for all of this is all greater than 13. So minimum answer, minimum will be minimum of all the summation from starting to its leaf will be, starting to last will be my answer, because I need to take off all that, right? So this is of course this is third row, right? This is the third row. This will be the third row. This will be third row. So so minimum, what will the minimum of all the summation from starting to its last will be my answer, right? In all the subject. So this is something like recursive, right? So we can do it in both ways. The first one is recursive and the second is iterative. So let's see how we can do this for recursive here. For recursive, what we can do is, so what we can do is for recursive, we can make we can we can make a reverse solve function here, and we will pass 0 and the first position, because at the first point we need to take all of the characters like 1, 2, 3, and keep track of the previous elements which I have taken, right? Suppose I have started from 0, uh, n plus 1, and what, and n plus 1, and this grade, the something like this. So what can we choose in the first row? This is the first starting point, the 0th point, and I have taken 0th. Again, this is the 0th point, I have taken 1. Again, this is for 0, this is 0, and I have taken 2. Now again for second, I can't choose 0, so I need to iterate in all of this. So iterate I need to iterate in all of the columns. I need to iterate in all columns of a particular row and find the minimum between all of them, and find the minimum of all that. Right? I need to find the minimum of all of the all of the particular columns on that row. Right? Minimum of all columns of that particular row. Right. So this is how, just, and we will simply start from from any row, right? I need to take in all columns particular row and find the minimum of all the columns of that particular row, right? If you see that, what I have done, that I have chosen particular first row, and started taking all of the columns one by one, and according to that I will choose every column after that row, excluding the previous column which I have chosen, right? So this is how we can done this question recursively, right? This is how we can done this question recursively. And again I will iterate in whole columns, and I will call for this first one, and also for 1 comma 2, which is, and what I will take, I will see the minimum of all of this. I will see the minimum of all of this, minimum of all these answers from here, then here. Then again for this solve one, again I can call minimum of solve of 2 comma 0, 2 comma 2, again minimum of solve of 1 comma 2 comma 0, 2 comma 1, and again I will take the minimum of all of this minimum. So this is how we will find for this, then again this, and again this, and find all the minimums of all the summations. This is can be the approach for recursive here, right? So let's see how we can done this in implementation. So the first thing is I need to figure out the how we can do this in grid size. So here it is given that width and the height of the grid is same. So I will take only this grid, and I will call this solve function with 0, and I will take n plus 1 for handling the first row, right? For handling the first row, and I will call this particular row, and this is the previous column. This is the previous column which I've chosen, and this will be the vector grid, right? So now, what will be the question that I will start iterating in whole columns of that particular row, and if this column is not equals to my previous chosen column, then I will again call this. I will include this current in my answer, and again call this for next row, and this previous call will become my the current row, the current column, and I will call this function as a grid. So what will we, so I need to see for every column, and among them I need to find the minimum of all of them, the minimum of all of them. I need to figure out the minimum answer for all of them, right? So I need to check for every column, and check that from which column I will get a minimum value for that answer, and I will store in and return it simply, right? So what is why this n plus 1? This n plus 1 is for the first row, because the first row, in first row I need to take all of the columns for that first row, because we have not chosen any column previously. So I need to choose a greater than the column one, so that this will not intersect with any particular column. So I need to take n plus 1, right? So let's see whether this passes or not. So this is a this is a recursion for just a minute. I think some grid okay, this will be the previous column. This will be the previous column. Okay, this is a row. This is not column. This is I. This is not I. This is a row. So this is row plus 1. And again, I don't think so. Let's see. So this is a recursion. This will give a TLE. So we need to memorize it further. This will give TLE. Uh, okay, I have not also included a base case. So when this recursion will stop? So if what we are changing, we are incrementing the row always, and this j is will be always less than n. So I need to maintain a base case that when this recursion will end. So if this row is greater than the length of rows, the total number of rows, then it will return 0, right? So why I have taken 1e9? Because in this the minor negative elements are also there. So if I take this as -1 or something, that then it will give me some errors because negative numbers all can also be included, right? So I need to take is 1 in 9, and this will be the minimum answer. So let's run again. So this is a recursion. I need to memorize it further. Just seeing that we as are we are passing the sample case. Yeah, this is we are passing sample case, but here can be some uh, overlapping problems like this 4 9 and 4 8. This see this 4 9 and 4 8 is same in all 5 7 and 9. 5 7 and 9 is same in all 6 8 9. 6 8 9 is all. So there are many sub problems occurs in between, so we need to just memorize it further. So for memoization, I will just include this int n plus 1 0. Okay, 1 in 9. Again, why I have taken n plus 1? Because I am storing n plus 1 in this here, so I need to take an extra here. I will pass this. This will again dp. So I need to check whether this dpi or previous column is already wasted or not. Then I will simply return this value if I don't have this previous value and column, right? Okay, let's see. Okay, this will be a row. Why I'm taking I as a again and again? I also need to pass here dp. Let's see. Mm, it is giving runtime error. 0 to n plus 1. Okay, I have passed n plus 1. I can pass also n, because I have declared it as n plus 1 here. So now this should be fine because elements can be from 0 to n minus 1 only. So I need to take a greater than n minus 1, which can be n, right? So I can take n plus 1 here. Now let's run this. So I need to take this n because this will be overflow otherwise. Let's submit it. Yeah, we have passed this test cases. So what will be the time complexity for this recursion part? So the time complexity, will be what will the time complexity? We are choosing a particular row and we are taking every column for a particular row and making it as a previous column, and then again I am choosing same column and checking all the rows. So what I'm doing, I am taking for every row and choosing one column and checking for every rows for the next column. Again I am choosing the same column for a particular row and choosing for the next for and seeing for the next row for every column. So the row is movable only one time, but column is chosen two times here. One for the first we have chosen the first column and seeing for every column for the next row. Again I have choose the second column and seeing the for every column for the next row, and again I choose third column and seeing the next row column for every column for the next row. So what will be the time complexity here? That will be O of n for row and O of n into for a choosing a particular column, and then O of n into her for iterating the all columns of the next row. So that will be O of n q, right? And again if you so this will be the space complexity, and the this will time complexity, and the space complexity will be O of n square, because I'm only taking this dp added here extra, so that will be O of n square. And if you also choose the recursion stack space, that will again O of n square. Yeah, O of n square, because this recursion stack extra space will be taken. So how will I remove this recursion stack? So this will be O of n cube, which is 200, so that will return to power 6, so that will be that can help that can handle this. That's why I told you this is a medium, very medium BFS, very medium problem, because this is simple recursion plus memoization problem. If one have solved enough questions in recursion plus memoization, then he can solve easily. Sorry. So how we can remove this space complexity here, right? This extra recursion stack space. So let's see it iteratively, right? How we can solve this in iteratively. So sorry. So what I am doing here. So what I was doing in iterative, we are taking every each column. We are taking each column. Okay. So what will the base case here? So the base case is simple, that I need to take every we need to take. Oh, sorry. So one will be the base case here. So we need to take each column each column of the first row, and accordingly seeing that which particular column should not be included in adjacent rows, right? Right. So what I was doing, it I will take all the columns of the first row, and I will I will choose a particular column, that I will not choose this particular column for my second row. I will not choose particular column for my second row. I will not choose my particular column with this with my second row. So I need to make again choices between, by saying that this will not choose in by second row, this will not choose in by second row for each and every column, right? This is how we can see this. So what we can make changes here, just nothing, that I will simply insert all the columns for my first row in my DP, right? In my DP 0j 0j, I will insert all the elements in my first row. I've taken all the columns in my first, right? And I will start iterating from second column. And what we are doing, that I was checking that this previous column should not be equals to my current column. Then I will only increase this. Uh, then I will only increase this. So what will I do? I will start making choices by taking every column, previous column plus plus, right? I will start making every column, that I will not choose this previous, I will not choose this previous again and again. So for that, I will just include this in my answer. I will just include this my in my answer, that for every for every previous column, I will not choose this in my previous column. For this previous column, I will not choose this in the previous column, and the answer will be including this row. So this row will becomes I, and this row, and so this solve becomes this TP. So we are doing a bottom down. So this row plus 1 will becomes I minus 1, because we are going from 0 to n minus 1. Previously we are going from, so this will be I minus 1 to j, right? And this this dp will be I minus 1 here, and this j will become now the previous one, simply this d and this j here. This is how we can solve this. So answer will be the minimum of all of this, simple, and we will store this in my DP of ij. This will be stored in my DP of ij, here, like this, right? This will be stored in my DP of ij. So this will be stored in my DP of ij. What we are doing, that we are storing this previous, we are taking a particular column. I will not include this in a particular column, and trying summation with current element, and including in my minimum of this TP of ij, which is here, and just insert this, right? And now I need to see, so what will this TP of ij denotes here? dp of ij denotes dp of ij denotes that the minimum summation till ith row and jth column, if that includes minimum summation till ith row from zeroth, from starting, and the jth column, right? This is the dpij denotes here. This is dpij denotes here, right? So after this loop, I need to find the minimum value, which is my last row. At last row, I need to find the minimum value which is in my last row among all the columns. So I need to find the minimum of answer dp of n minus 1 and the particular and every column. So this will be my answer here. uh, Something again happened. Why it is coming 13 here? Okay, this should be. I need to take a minimum of all the last values. I have taken this first to n, previous columns to 0. I started from j0 to jn and will not include this previous column. Then I will choose this dpij for every row, dp of I minus 1 to j. This grid ij will be the answer, dp of I minus 1. Okay, if I don't choose this previous column, okay. So this will be the previous call. So this will not be a j value here, because I need to because I already chosen this previous column in my answer, in my previous row. So this should not be for the previous row. So for grid ij plus previous column which I've chosen, that will be should be answer. Let's run this. This should not be j. This should be previous column. Yeah, we have passed this case. Let's submit it. We have successfully passed this test case. So what will the time complexity and the space complexity? So the time complexity will be the same because we are taking three loops here. So the time complexity will be O of n cube again, and the space complexity will be O of n squared, because and there is no any recursion stack space for this. So this will be O of n squared here again, right? So if you see this here, we are just doing this is the same as the recursion. So iteration and the recursion is something similar but with a different value. So what if this, so this question has less constants, so that's why O of nq is valid. But what if it is given as 2000, right? Then how will this question will not be solved accordingly. So let's see how will I find this optimal solution from here, right? So if you see what we are doing, we were doing that we are taking the minimum of all the column with minimum of all the columns in a particular row. And again I was going down and checking that, checking for the previous minimum column which I have chosen, and including in my all columns of the next row, and then seeing that the minimum of all, what will the minimum if for the second row, again for doing the same. So what we are doing, we are we are just finding the minimum possible summation for a for a for a particular row by checking every each and every column, by checking each and every column, right? This was we are doing. So if we focus on, so all the focus is on minimum possible summation, minimum summation, right? All the focus is minimum possible summation, right? So what if I, what if I, instead of doing this previous column, instead of this previous column, what if I store, what if I only store the minimum value occurs till ith row, right? If I store this minimum value till ith row and check for the second row that this value is not possible for that column, then I can choose this, right? What does it mean? Suppose this is 1 2 3 is given, right? This is one, suppose this is 1 2 3 is given, this is given 4 5 and 6, right? So for this, if I store the first two minimum elements, if I store this first two minimum elements like this, 1 2 3 is here. So what will the first two minimum elements, 1 and 2? And you will know, uh, as I explained, that why I am choosing this first two minimum elements. If I choose 1 2 here, and for the next row, if I see this 4, if I want to choose this 4, and I will see that whether my previous column, it's this column previous row, this if I choose this column, so I will see that the previous rows with the same column has my minimum value or not. So if uh, one is the minimum column which is already included, then I will not add with this one, I will add with this 6 or 2 value, right? So this 4 now becomes 6, right? This 4 now becomes 6. This 5 value, this 5 value column in my previous row was 2, so I cannot include this, so I will store, I will add with this with 1 only, then this will become 6 only, right? For 6 I can choose both 1 and 2, because I don't, because this previous column is 3, so I can choose both 1 and 2, so I will choose minimum of both of this, so that will become 6 plus 1 7, right? So this is, and so what I will do for the next row, I will store minimum of both of these two. I will store minimum of both of these two. 1 2 3. So for minimum, so what will you do? I will store both of this. So 6 will be the two minimum elements for this. Why I am choosing two minimum? Because if the previous column of the particular row is same value as my minimum, then I will choose the second minimum. Otherwise, I will choose the first minimum, which is the lowest minimum value of both of these two. Right. That's why I am choosing this two minimum. So for 7 8 9 9 here. See, if I choose 7 here, then its previous column is 6, which is in my minimum element. So I will choose this. I will choose the second minimum element, which is 6. So 6, 7, 6 is 13, right? If I choose 8, its previous element is 6, which is included in my second minimum element. So I will not choose this second, I will choose this first minimum element, which is 14. And again, for the 9, I can choose any of this because its previous element is 7, which is not included in both of the minimum. Then I will choose the lowest minimum possible, which is 9, 6, 15, right? So now I will see the minimum of all of these, which is 13, which is 13, and that will be my answer here, right? So what I've done, I have done that instead of choosing every column, instead of checking for every column, previous column, I will just store minimum element and checking for the two elements only, checking for the two columns only. That if this is not, then this, and this is not, then this. So do you think this is a particular another problem? This is a particular another easy problem which I have used, which I've used here. What is the problem here? For finding the two minimum elements of an array. This is the lead code easy problem, that finding the two minimum elements of an array. This is the same which I are using here. So the first approach is for this. First approach is first approach for this finding the two minimum is that short sorting sorting and find first two elements. That will take O of n log n, right? That will take O of n log n. The second approach is maintaining maintaining two minimum two variables for minimum for finding the minimum elements. Finding the minimum elements. Finding the minimum elements. And if you see, so for finding the minimum elements, right? Finding the minimum elements, right? For finding the minimum elements, right? So this is how we can solve this. Finding two, maintaining two ways, find the minimum elements. So let's see how we can done this. So what we are doing, we will not choose taking each and every column. So this loop is not needed. And what will I just change in here? I will take an extra loop. I will take an extra loop, and I will make a two variables for storing my two minimum values. So how will I use this for storing? So if this mn first is greater than my grid I value, grid I minus 1 value, because I need to find its previous two minimum values. So I will need to take grid I minus 1 j. So this mn1 if is greater than this, so I will include this in my answer. But before that, I need to shift this to previous already numbered with mn2, so that we will find the two minimum elements. But if this grid I minus 1 j is greater than mn1, I will check that whether this mn2 is greater than this grid I minus 1 value or not. If it is greater than, then I will insert this in my grid I minus j value. Sorry guys. So how this is working? This is, suppose here it is given 5, 6, 6, 7, 8 and 9. So if this is working 5, 2, 5, 1 and 2. Suppose I got 5. this mn1 is 1 in 9, it is greater than this grid I minus 1j. So I will assign mn2 with this mn1 which is 1 in 9 already, and mn1 to 5. When 2 comes, it is less than 5, then I will assign mn2 to 5 and mn1 will become 2. Again, when 5 comes, it is greater than this grid, and this mn2 is equals to this grid I minus 1 which is already 5, right? So mn is 1 is 2, mn2 is 5, right? So when 1 comes, mn1 is less than mn1 is greater than, then I will change, then I need to change this with to 1 and mn2 to 2, right? This line. And when it comes to 2, this is less than 1, so I will not make changes, and this is equals to 2, so I will assign second 2. So this is how we will find the first two minimum elements here, right? Now it's time to use this mn1 and mn2 for my changes. So what will I do if this grade I minus 1 value, this previous value is here, is not equals to mn1, then I will just add in my previous value, right? I will just, okay, this should be the dp here, this should be dp, not grid, because I am adding in my dp, not grid. If I was adding in my grid, then I need to take a grid. I'm adding in this my dp. So if this dp I 5 minus 1 is and mn1, then I will not take this, I cannot take this mn1, so I need to, if this is not mn1, then I can add this mn1 here, right? And if it is not, if it is equals to mn1, then I cannot take mn1, and I will need to choose its another option, which is grid ij plus mn2, right? So I'm making adding this dpij, and just see, what was I doing, that I was adding one, taking 1 to 3 and adding the minimum of both of this, and then I was choosing the same minimum elements after making changes in this. Then I was using that minimum elements to for again and again. So that's why I am making changes dp of I. That's why I need to check for the previous dp values. And finally, the same approach for this, that I will go to its last row and find all the minimums. So yeah, this will should work fine. Let's run it. Uh, okay, this should be not here. This should be at top position. So what does this mn1 is doing? That if it is not equals to mn1, I can include this mn1 because this is the most lowest element of previous rows. And if it is equals to mn1, I will include mn2, right? Okay, let's run. Yeah, you submit it. Uh, I think there are net issues. No problem. We will wait. Mm, this should not give TLE, right? I think there is net issues. Uh, I don't know why it is not giving me summation. Let's submit it again. Yeah, we have passed this case. That was just some glitch here. So yeah, this is how we will find this. So what is the time complexity in the space complexity? So we are only iterating uh, O of n times, right? So that will be O of n square, because we have uh, we have changes that previous column to finding this minimum element. So this is O of n. For finding this minimum element, this is O of n, and this is O of n, right? So this is not a nested loop. This is a parallel. So this take O of n, this take O of n, and this is O of n. So that will be O of n square total, right? And the space complexity will be O of n square again. So for finding, for changing from n cube to n square, that makes it somewhat difficulty, right? So that's why it is a hard problem if you choose to make it O of n square. Now again, the further optimization can be occurred for changing this space complexity to O of one, O of one. So I will not give you implementation here. I will just give you hints. Try to do it in yourself, and uh, send the code in my comments section. Let's see uh, who can do this, right? So this, how can we make this O of n square to O of one, right? So if you see, we are just using its previous elements, right? We are just using its previous elements. Okay. You can do it O of one also, but if you can also do it in O of n also. So let's see who can do it O of n and who can do this in O of one. So I will just give an hints for that we are using its previous rows always again and again, right? Let's see, you see dp of 5 minus 1 j and dp of 5 minus j. We are using its previous rows again and again, so we don't need to store the whole dp array. For uh, we can choose a single array also, and also two elements only, right? We are using its previous rows only, previous rows only for a particular column. So this is hint for O of n, and the same hint for O of 1, and the same goes for the same goes for the hint for the O of 1, that you need to see only the minimum 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 summation, minimum values of previous and current rows, right? So this is hint for O of n, and the same hint followed by this line is for O of 1. So uh, so what you can do, try it try it your own. See, make some example, take some examples on pen and paper, and try to implement it, and comments down below your code. comment the code Comment the code below. Let's see how many can you do on comment the code, right? So this is uh, homework, right? So yeah, this is we can do. I've told you till the O of n square and the space comes to O of n square. Let's try to optimize it further. Thank you. Uh, this is a medium problem, but by changing it to from O of n to O of n square, it will come hard. By It's a game of constants only, right? So it depends on only on your interviewer, that uh, what and at which level, at which stage he will be happy, right? So yeah, thank you.